Well, hello everyone, and welcome to Weekly Review Live. It's been a long time since I've been here. A bit of a hiatus, things going on, but I'm back. I'm ready. Let's do this. A special week. We wrapped up Unit 13. That's why I specially wore my Noble Gas shirt today. Yeah, bad chemistry humor. I'd tell you more jokes, but all the good ones are gone. Hey, it's Friday. Let's get going here. I got a post-it note that tells me what to talk about. Then I got another post-it note that tells me what to talk about. Then I got a problem that tells you what to think about. Let's do this. Oh, by the way, sorry about the audio quality here. It's probably kind of crummy. I left my microphone. Oh, boop, 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 boop. Never mind that. I left my microphone at home from a course that I was teaching yesterday, so just using this one, it's probably really echoey. That's why I'll try and keep it a little quiet so it's not so echoey. But also, I'll try and keep it short for you. So anyway, okay. So this week we did gas laws. It was all Unit 13. We started off with Boyle's Law, which was video 13.4. That was pressure times volume. Well, pressure and volume are inversely related. As one goes up, the other goes down, right? Remember the pencil trick. Point, pressure, volume, eraser. I know, no connection. T, temperature. Temperature stays constant. As pressure goes down, volume goes up. Pressure goes up, volume goes down. Inversely related, because they're not proportional, so it's not indirect. But the formula was P1 times V1 equals P2 times V2, but you don't have to memorize that because it comes up later. Then we got into Charles' Law. That was video 13.5. Here, let's put that there. 13.5, and that says that volume and temperature are directly related, which means as one goes up, so does the other. Kind of makes sense, because as volume goes up, so does temperature. If temperature goes down, so does volume. Whatever happens to one happens to the other, and they are directly related, so they're actually proportional. If you double the temperature, you'll double the volume. If you decrease the temperature by a factor of 2, you'll half the volume, kind of a thing, right? So that gave us the formula V1 over T1 equals V2 over T2. Again, you didn't have to memorize it because they all get wrapped up into the combined gas law, which is video 13.6 on the YouTube channel or Google Drive. So the combined gas law is on the back of your reference table, and it's P1 times V1 over T1 equals P2 times V2 over T2. And the deal is, if you ever have a problem where they ask you to solve for something, you can always start with the combined gas law. And if anything doesn't change, you can, let's see if this is going to work. And if anything, there we go. Whoa, hang on. Sorry, technical glitch. Uh-oh, come back to me. Oh, there we go. Okay, whoo, that was scary. So you can always start with the combined gas law. And if something doesn't change, if they don't mention it, or if they specifically say in the problem that it remains constant, you can just drop that out of the combined gas law equation because it would cancel itself out. So this is where writing down the formula is so important, because all the time people forget whether P times V, P divided by V, what the heck. Look at the reference table and make sure you know it. So with that, let's take a look at a sample problem that I have set up for you here. Ba-boom. Oh, there. Is that going to do it? There we go. So it says, a 3.2 liter sample of gas has a pressure of 209.6 kPa. What will be the volume of this gas at STP? Now, this is a little bit tricky because some things are hidden, but we talked about it. So if I start with the formula, P1 V1 over T1 equals P2 V2 over T2. So let's see, they talk about volume, they talk about pressure, they didn't talk about temperature. I should have mentioned that, but I didn't. So hey, how about that? So in this case, since this problem doesn't mention temperature, I can just take it out of the equation altogether, right? Because it would cancel itself out. Now you may say, yeah, but temperature is part of STP. That's true, but it didn't say what the initial temperature was, so it couldn't have changed. So let's see, what did they ask me for? Let's change ink here. Boom. What will be the volume of this gas? So I'm looking for the new volume. I should be able to find everything else. So the pressure it started at was 209.6 kPa, right? That's right up here. And that I'm going to multiply by the initial volume, 3.2 liters, good, 2 liters, equals, I'm looking for the new volume at STP. Now, don't forget, STP is in your reference table. It's on table A, and the deal is there's two values, so you really just want your units to match. So since it's kPa on this side to start with, I'm going to choose 101.3 kPa to end with. Let's erase this to clean it up a little bit. There we go. And we'll do times V2. Now I can kind of guess this, right? If I do the pencil trick, put the pencil in your finger. Yep, do it right now. Do the pencil trick. And when I look, the pressure goes from 209.6 to 101.3. So the pressure is definitely going down. And when the pressure goes down, that means the volume has to go up. So my answer needs to be greater, right? Let's see, volume has to be greater than 3.2 when I'm done. So let's do some math. Let's switch ink color. We'll go with, yeah, orange. Why not? So if I combine like terms right here, if I say 209, calculator of science, 209.6 times 3.2, I get 670.72 equals 101.3 times V2. So to solve now, I want to divide by 101.3 on both sides. 0.3, and when I divide by 101.3, I'm coming up with V equals 6.62, we'll call it. And since my units of volume were liters to start with, they'll be liters at the end. Now let's check back up to our guess here. We said our volume has to be greater than 3.2. 6.62 is definitely greater than 3.2. So we're in pretty good shape there. Excellent. So let's come back here. Cool. So that's our problem. Not too bad. Remember, no matter what, you can always start with the combined gas law and just drop anything that it doesn't mention or that it says stays the same. Cool. From there, it was a little bit disjointed today, but either today or yesterday we talked about Dalton's law of partial pressures, which was video 13.7. That's just the idea that all of the pieces have to add up to the total. So in terms of a Regents question, they're either going to give you all of the pieces and ask you for the total, or they're going to give you the total and all but one of the pieces and say, what's the piece, right? It's like we did on homework page 4. We also talked about Avogadro's law, which was 13.8, and Avogadro stated that any two gases, regardless, there we go, I keep getting off screen here, any two gases, regardless of what they are, at the same condition, same temperature, same pressure, same volume, will always have the same number of particles. Pretty straightforward. And the last thing was the collision theory, 13.9 in Google Drive or YouTube. And collision theory states that in order for a reaction to occur, particles have to hit. They actually have to collide. But it's more than just hitting. They have to hit effectively. They have to hit correctly. To make them hit correctly, it has to be at the right, what did I say? Speed, right? The proper energy and the right angle, the right orientation. So it's all about the right amount of force and the right angle that they hit at. And that's where those big cannonballs came into play. So cool. So what I thought is this morning, I posted a question, the Bluestone Cafe trivia question of the week. Let's take a look at that real quick. Where is it? Is this it? Yeah, I think this is it. Share. Yeah. So up on Twitter, let's see, where is it? Here we go. What volume in liters would a 1 mole sample of Rn occupy at 200 kPa and 100 Kelvin? So I thought you'd be able to figure this out, but nobody came up with the right answer. So then I gave up a little teaser and said, think gas laws, because this was a combined gas law problem, and think what you know about 1 mole of a gas. So what the heck was this saying? Well, if we flip over to the iPad here, let's see, iPad. It said that, let's make this a little bit thicker so it's easier to see. Is that working? Yep, okay, good. Still learning this. It said that I wanted to know about 1 mole of a gas at 200 kPa and 100 Kelvin. So I asked, what do you know about 1 mole of a gas? Well, I know that 1 mole of any gas equals 22.4 liters at STP, right? And the reason I'm going through this is because maybe this question is going to show up again later and it'll help you out. So 22.4 liters at STP, that means, and since I gave you kPa, we'll use again 101.3 kPa, right? It's 22.4 liters, and STPs in terms of temperature is 273 Kelvin, right? That's STP. So that's one part of it. I know that at STP, 101.3 kPa and 273 Kelvin, 1 mole occupies 22.4 liters of a gas. I want to know what will be the volume at, I said, 200 kPa and a temperature of 100 Kelvin, right? So if I cross multiply, when I go this way first, I came up with 54,600 times the second volume equals, when I go this way, I get 101.3 times 22.4 times 100 is 226,912, right? So I have to divide both sides by 54,600. Let's make sure that's a clear comma. 54,600. And the new volume has to equal, I came up with we'll call it 16, and that would be liters, right? So that's how you solve that one. Now, because I gave you the answer, that means right now, the Bluestone Cafe trivia question for this week is over and nobody gets points for it. But that doesn't mean that question won't show up later in some way. Could show up on the test, could show up on a Regents exam, could show up on another Bluestone Cafe trivia question of the week. So hopefully you'll do better at it then. So sweet, that wraps up this Post-it note. Now we're on to this Post-it note, which is upcoming information. This one goes a lot quicker. First off, the Unit 13 exam, this unit, gas laws. When is that going to be? I don't know. It's going to be next week sometime, but we have so much stuff going on next week. I don't know. I'll try and let you know for sure on Monday. I'll try and post it to Twitter over the weekend and let you know what's going on. But that's my plan. Oh, look, there's a notification on, nope, not what I thought. And what else do I got going on here? Unit 12, the Unit 12 makeup exam is going to be Wednesday, the 25th. I want it before spring break, and I'm gonna try and make some tutorial videos for you this weekend and post them up, and I'll let you know here once they are live, so that way you can get help with that. Again, only the Unit 12 material will be able to change. The review material will not be able to change that grade, just the Unit 12 stuff on phases of matter and intermolecular forces of attraction. 6 weeks ended today, so hopefully you got all your stuff in, you've been keeping track of that. And to let you know as a heads up, that means in about 3 weeks, marking period 3 ends. That's bonkers. Marking period 3 is ending. Holy crow. But that ends April 17th. That's a Friday. So you want to check eSchool, make sure if you're missing things, you talk with me, get those in. Maybe it's going to be credit, maybe it's not. Who knows? But you want to make sure that any missing work is getting in, or any late work is getting in, or anything from when you were absent is getting there, because I know there's a lot going on. So with that, that's the end of that Post-it note. I am all done. Hope you had a great week. Hope you enjoyed the assemblies today. I wish you all the best of luck with everything that's going on next week. It's going to be insane, but we'll get through it together. And with that, I am out of here. Have a great weekend, everybody. Bye-bye.